Okay, let's dive in. You know that feeling, that really fundamental human thing where we just need to find order in all the chaos?
Yeah,
It's
absolutely.
just in us, isn't it? Whether we're trying to figure out our own messy thoughts or, looking up at the night sky, trying to see the patterns, wondering how it all connects.
Mm.
Well, what if there was like a single system, a universal method designed to describe the structure of everything, how complex stuff emerges, how things relate, how they change, maybe even linking abstract ideas to physics, even consciousness.
That's a huge ambition, and that's exactly what we're tackling today. Welcome, everyone, to a deep dive into Burkhard Heim's Syntrometry. It's complex, definitely theoretical.
And we're basing this exploration on, well, a pretty hefty source document. Let's just call it the Heim paper or the source material. It really lays out the core concepts meticulously. It's dense stuff, for sure.
Yeah, it is. But our mission here is to, cut through some of that density. We want to pull out the key ideas, get a handle on the building blocks Heim was proposing.
See how they fit together to build complexity.
Right, and explore some of the really remarkable claims he made. I mean, connections to physics, consciousness.
Right.
It's pretty wild stuff.
Think of this as maybe a shortcut, a way to get a grasp on this attempt at a truly unified picture of reality's deep structure. It's definitely a journey through some abstract territory. So, welcome you to this deep dive. Let's jump in.
Okay, so at its most basic level, Heim's system starts with something pretty intuitive. How we see or understand reality really depends on our perspective.
Yeah.
He calls these subjective aspects. The core idea is that meaning, even what we consider true, is absolute. It's relative to the specific way a thinking process or a logical framework is set up.
Okay, so it starts simple. Your viewpoint might differ from mine, but he actually makes this formal, doesn't he?
He does, yeah. He formalizes a subjective aspect S, or SMOD X, in a more modern notation and says it has an internal structure. It's got basic elements like qualities or ideas. He calls them qualifiers or diatropes, and then what we can say about them, the predicates.
Okay.
But crucially, they're not just like a random collection. They have to be linked meaningfully within that perspective. That's coordination. He uses terms like chiffering coordination and coordinations bender. It's about how the relevance of qualities connects to statements about them.
So coordinated pairs then, those represent actual thoughts or perceptions within that framework.
Exactly. They represent the structured thoughts or perceptions. When elements are properly linked, you get structure.
So it's really about how the pieces connect inside a specific point of view, which sounds like it leads straight to this idea of aspect relativity.
Precisely. That's a cornerstone principle for him. Everything, at least at this initial level, is understood relative to a specific subjective aspect.
And to make that rigorous.
Yeah, to formalize it, the source uses tools from logic, things like cryptic semantics. The different possible perspectives, these aspective systems, form a kind of space. And he introduces a concept called metropg to measure the formal distance or relatedness between these perspectives.
Ah, okay. So you can actually map out how similar or different viewpoints are, formally speaking. Within that space of perspectives, what does Heim say is necessarily true? Is anything?
Well, he introduces aspect necessity, written as OS. This means something is true or apodictic, but not absolutely everywhere. It's true across experientially or conceptually close worlds, basically. Other subjective aspects that are pretty similar or easily reachable from the one you're in.
So necessarily true within a certain context or level?
Exactly. It captures those invariant elements within a given frame. And there's a rule, fact S, for just introducing basic facts that come from a specific perspective.
Okay, so we got perspectives, how they relate, what's necessarily true from a similar viewpoint. Where does he go from there?
Well, this naturally leads to the big question. If truth is relative, can we find anything that's true universally? True across all possible coherent perspectives. Heim calls that a universal quantor.
A universal truth bearer.
Right. And the search for a formal structure that could actually embody this kind of absolute invariant truth is what directly motivates the next big concept, maybe the most central one, the syntrics.
Got it. So from relative viewpoints to the hunt for universal truth, which brings us to the syntrics. What exactly is this thing Heim proposed?
The syntrics, denoted, is Heim's formal engine, you could say. It's designed to generate structure that could potentially embody that universal truth. The source defines it pretty concisely as Sei, higher. Think of it like a fundamental recipe or blueprint for building structures of any kind, starting from the absolute basics.
Okay, universal structure generator. Let's break down that formula.
Okay, first up is the metaphor, the symbol. This is the absolute foundation, the starting point. It's a finite, ordered set of initial, unconditioned, totally apodictic elements.
Apodictic meaning?
Meaning necessarily true, invariant, unquestionable. These are the primitive truths, the core concepts or qualities the whole system is built on, the fundamental axioms, basically.
The absolute ground floor.
Okay,
And how do you build up from those?
that's the job of the scintillator, the symbol, often written as F. This is the recursive generative rule, the functor. It's the specific rule that takes elements from one level of the structure and uses them to produce the next level. It's the engine driving emergence, building complexity from simplicity, step by step.
And applying this rule over and over creates what?
It creates the syndromes, written as faux or proc. These are the layers, the levels of structure you get by repeatedly applying the scintillator, starting from the metaphor. Level 1 structures come from the metaphor, level 2 from level 1, and so on. The syntax itself is the whole hierarchical thing that results.
Makes sense. Build up complexity layer by layer from fundamental truths using a fixed rule. Now, the source mentioned syntactic stability, stab in this operator. What's that about? Is it different from the OS we had earlier?
Yeah, it's different. This captures the internal necessity, the structural soundness within the syntax hierarchy itself. It's not about truth across different perspectives like was. It's about whether a structure is validly formed, correctly generated from the metaphor according to the scintillator's rules.
So it's about being well-formed within the system.
Exactly. The source mentions a lift operation, which suggests the stability kind of propagates up through the levels as you build. Stability is inherited.
And you can trace how any piece of the final structure got there, its ancestry.
Yes, that's tracked by the immediate generative parthood relation, IGPK. It basically keeps a record of which elements at level K1 were used to build a specific structure at level K.
Fascinating. So everything has this traceable lineage right back to the fundamental metaphor elements. Now, here's something that sounds really profound. The source claims there's a very small set of ultimate building blocks for syntrometry itself.
This is a really key insight, yeah. Heim argues that any syntax, no matter how complex it gets, can ultimately be decomposed into combinations of just 4 basic types of structures. He calls them elementary structures.
4 types. That's it.
That's the claim. These are the irreducible syntrometric elements, and they're defined by combining just 2 simple properties of the scintillator, the generation rule. First, does it allow elements to repeat? That's heterometral versus homometral. Second, does the order of elements matter? That's symmetric versus asymmetric.
So combining those 2 pairs gives you 4 possibilities.
Exactly. Those 4 combinations are like the system's universal atoms of structure, the absolute basic ways things can connect and build.
Wow. So like 4 fundamental shapes or connection types that can build any possible structure in this whole system. That's a powerful claim for simplicity.
It really is. A universal, finite basis. And the source also makes clear that syntraces aren't always simple pyramids. They can get more complex. Homogeneous ones can draw inputs from all the levels below, not just the immediately preceding one. That allows for richer connections.
Okay.
Then there are band syntraces, which use continuous elements, not discrete ones, maybe useful for modeling things that change smoothly. And complex syncellatorin allow for more dynamic, nonlinear growth patterns, even rules for when the structure stops growing.
Sounds like a very flexible toolkit for describing how complex structures get generated. And the source mentions something about reflexive self-reference within this.
Yes, that pops up. It's noted as being particularly important for Heim's later ideas about consciousness. It's linked to something called the reflexive integration hypothesis, or RIH. The idea is that the syntax structure itself might be able to model a system that can somehow integrate or, be aware of its own state.
Interesting. Okay, so we've got relative perspectives, the search for universal truth, the syntax as this engine for building structure from fundamental bits, capable of complex forms, maybe even self-reference. But how do different structures, different syntaxes actually interact or combine? If you have 2 structures, how do they form a bigger one?
Right, that's where the corporator comes in. It's symbolized by, this is a different kind of operator specifically designed to map and combine entire syntax structures.
And the source says it has a dual Wirkung, a dual action. What does that mean?
It means when it combines 2 syntaxes, it doesn't just glue them together superficially. It acts simultaneously on both their foundational elements, their metaphors, and their generative rules, their scintillators.
So it combines the starting points and the building processes.
Exactly. It's merging the essence and the dynamics of the input structures.
And what are the main ways it can do this combining?
Well, the two main modes described are coupling, or K, which is more like a direct linking or association between specific parts or layers of the input structures, and composition, C, which is more about functionally combining or aggregating them into a new integrated whole.
And the specifics of how they combine.
That's defined by a Prädikatverknüpfung, which is basically the logical rule for the connection.
Okay, and depending on how they combine, you get different kinds of overall resulting structures.
Precisely. The source outlines two main architectural results. One is called a concenter. This leads to a sort of hierarchical or maybe parallel setup where the original component syntrices still keep some independence within the larger structure. Think of like stacking blocks or putting them next to each other.
Okay, components remain distinct. And the other type?
That's the exenter. This results in deeply integrated networked structures that are described as conflexives. The parts really influence each other mutually within a shared field, a conflectionsfeld. Think more like weaving threads together so they form a single, tightly bound fabric.
Ah, okay, much more integrated.
Yeah. And the source also mentions pseudoformen, which seem to be like default interpretations if the combination rule isn't fully specific.
This combining process seems absolutely essential for building up complex, layered systems from simpler parts. And Heim makes a really significant claim about this process itself, doesn't he?
He does, a very striking assertion. Jede Syntrix-Korporation stellt somit einen universal Quantor dar, which translates to, every Syntrix corporation thus represents a universal quantor.
Wait, the act of combining represents a universal truth.
That's the argument. Since he's claiming the Syntrix is the right formalism for universal principles, then the very act of formally and consistently combining these stable structures itself generates a universally valid truth about the resulting synthesis, about the properties of the new combined thing.
Wow, okay, so the valid combination is the universal truth in this system. And these stable structures that are formed by combining, they're called Gebild.
Yes, Syntrometric bildet. They're the stable entities that result from these corporations, especially the integrated excenters.
And there's a special class of Gebild mentioned that sounds particularly relevant.
The Holoformen. Yeah, these are defined by having non-reduzierbar holistische Eigenschaften, non-reducible holistic properties.
Meaning the whole is genuinely more than the sum of its parts.
Fundamentally more, yes. And the source explicitly notes that a holoform that also satisfies that reflexive integration hypothesis, RIH, the self-reference thing we mentioned, that's considered a candidate for modeling a conscious system.
Ah, okay. So that ties back. A stable, integrated structure with emergent holistic properties and maybe capable of some kind of self-interaction or self-monitoring. That's the potential model for consciousness here.
That seems to be the connection drawn in the source, yes. And importantly, a holoform isn't just static. It defines its own Syntrixfeld, SF. This field includes its possible states, the Syntrix Raum, its internal geometry, the Syntrometric, and the dynamic rules that govern its changes, the corporator field.
So these holistic entities have their own kind of internal universe of possibilities and dynamics. Okay, so we've built structures, combined them, identify these special integrated holoforms. How does the system handle dynamics, change, evolution over time, that sort of thing?
Right. That brings in the idea of Syntrix Totalitaten, TO. This represents the total universe of all possible syntrometric forms that could theoretically emerge from a given starting blueprint, or generative G. It's the whole space of structural possibility.
The entire possibility space. Okay, what actually drives changes or interactions within that space?
As introduces aniphony. Yes, this is described as an intrinsic, inherent potential for change and interaction that exists within the Syntrix structures themselves.
A built-in potential for change. And how does that potential get activated?
Through operators called anythensyntrosen, or YC. These are often thought of as chains of corporators, the combining operators. They induce dynamic transformations on these totalities. They select structures, combine them in new ways, basically causing the system to evolve or change state. The source mentions they can be classified based on what they act on and their properties, like whether the change is reversible.
Operators that navigate and transform the space of possible structures. Are there, like, higher-level operators, too?
Yes. Syntrix Functoren, YF. These are operators that act on the entire Syntrix-felder, those fields associated with the complex holoforms. They can change the state of the holoform, alter its internal geometry, or even modify the rules governing it. There's a whole 3x3 classification matrix for these kinds of transformations mentioned.
So they model how these complex integrated systems themselves change and adapt. What about interaction with the outside world? How does a system connect to its context?
That's handled by the concept of affinity. It's described as an intrinsic tendency or propensity for a system to connect or interact with its environment or other systems.
An inherent desire to connect.
Sort of, yeah. Formally, the affinitate syndrome, S, quantifies this potential connection. It's defined in equations 19 and 19a. It can even capture different types and strengths of potential relationships. That's the orientiert affinitate syndrome. And if this potential stabilizes, it forms an affinitate syntrix, representing a stable interface for interaction.
Okay, so systems have a formal tendency to connect. Now, if we think about this dynamic process over longer timescales, evolution, the source mentions metroplexiondyne. What's that?
A metroplexiondyne basically describes a complex system, a metroplex, undergoing dynamic evolution through its possible states or parameter space over time. This evolution might follow a single path, monodromy, or it could branch out into multiple possibilities, polydromy.
And is this evolution just a random walk through possibilities, or is there some kind of direction to it?
This is where Heim introduces a really significant and maybe controversial principle, telecentric. He postulates that evolution, especially the evolution of complex structures, isn't random, but is inherently guided towards stable attractor states. He calls these telezentron, goal centers.
Goal centers, like purpose.
Essentially, yes. States of coherence, stability, or what could be interpreted as a kind of purpose fulfillment for that system. These telecentrons structure the whole evolutionary landscape into a hierarchy, an Anish area.
Purpose or goal direction built into the fundamental evolution of complexity. That's a major claim.
It really reframes how you might think about evolution, doesn't it? And it gets even more radical with the concept of Transensexstufen. This describes the possibility of qualitative leaps, where systems can jump to entirely new, higher organizational levels, maybe even different domains of reality.
Woo, like strong emergence. Something fundamentally new appearing.
Exactly. It's Heim's mechanism for addressing strong emergence, how something can arise that isn't just reducible to the sum of the parts on the lower level.
How does a system make such a leap? What enables it?
The source points to those affinidad syndrome, the potential to connect, and the stable holoformin as being the necessary structural precursors, the springboards for these leaps. There's even an overarching architecture integrating these levels called transcendental tectonic. And within any evolutionary path, you can have tele- and disvarianten paths that either preserve the goal-directed structure or alter it.
Okay. Structures are built, combined, evolve with purpose, can leap to new levels. How does the system handle really massive complexity, like structures built out of structures, which are built out of structures, and so on?
That's addressed by metroplex theory and the concept of metroplex NM. The whole system is designed to be recursively scalable.
Recursively scalable. What does that mean here?
It means you can build a system, let's call it a metroplex of grade N, where its basic building blocks aren't the original fundamental elements, but are actually entire metroplexes of the lower grade, N1.
Oh, right.
These lower grade systems form the hypermetrophore for the higher grade one. And the whole thing is governed by a higher order generative rule, a metroplex scintillator. The very first step up, the hypersyntrix, 1M, treats a collection of basic syntrices as its foundation.
So it's literally systems built out of systems.
Right.
Like nesting dolls of structure.
Pretty much, yeah. And the source emphasizes that the fundamental properties, like those 4 elementary structural types, the ability to combine their inherited all the way up through these grades.
But wait, if you keep nesting complexity like that, doesn't it just explode? How does the system manage that potential combinatorial nightmare?
That's a critical point, and this is where a process called contraction, kappa, becomes essential. The source brings it up multiple times, like in the context of metroplex theory and later with cascades.
Retraction, like contraction.
Exactly. Its job is precisely to manage that exponential blow-up of complexity you get in these deep hierarchies. It ensures stability and coherence. It acts like a mechanism for abstraction, filtering, maybe dimensionality reduction, selecting only the stable or relevant combinations based on intrinsic criteria.
So it's like the system's built-in way to simplify or focus, to stop it from collapsing out of its own weight.
That seems to be the idea, yes. It's crucial for making these deeply nested structures manageable and stable. And there are also ways mentioned to connect between different grades in the hierarchy, Syntrometric, Metroplex, Birken.
Bridges between levels. Okay. So we have this incredibly comprehensive framework for building structure, combining structures, evolving them with purpose, transcending levels, scaling complexity infinitely while managing it. How does Heim actually propose applying this hugely abstract system to the real, tangible world?
Well, the first major application is modeling the quantifiable aspects of reality. For that, he uses the quantitative syntrometrics, IRN.
The syntrometrics of quantity itself, what's its foundation? What's its metaphor?
Its absolute unshakable basis. This metaphor is the fundamental structure of algebraische Zahlkörper, algebraic number fields.
Like rational numbers, real numbers, complex numbers.
Exactly. The universal stable properties of numbers themselves. That's the bedrock for quantity in this system.
Okay, so the structure of numbers is the starting point. What does this quantitative syntrometrics generate?
According to the source, it generates emergent tensorial Scintillationsfelder, basically abstract metrical fields denoted 2G. These are the structured mathematical fields that can describe quantity, measurement, spatial relationships, things like that.
Abstract mathematical fields born from the structure of numbers. How do these fields get processed or combined to represent the structured, measurable reality we actually observe?
That happens through a process called Strukturkaskaden, structural cascades. The source describes this, pages 180, 183, as the model for how these metrical fields are hierarchically processed and integrated to form increasingly complex structures.
A cascade. Like a waterfall of structure building.
Kind of, yeah. It's described as a sequence of discrete steps, Kaskadenstufen, starting from a Kaskaden basis, which could be elementary fields or structures, and building up level by level to a Kaskaden speciv, representing the fully integrated complex field or structure.
And it's a logical process.
Yes, it's governed by an analytischer syllogismus, implying each step is formally derived from the one before it.
How do you actually get from one level to the next in this cascade? What's the mechanism?
It happens through partial composition. This involves structure association, where fields or structures from the previous level combine or associate with each other. This combination isn't arbitrary. It's mediated by specific interaction tensors, a correlation tensor F, and a Koppelungstensor Q.
Okay.
And crucially, these tensors themselves are derived from the underlying geometry of the fields, which is defined by something called the fundamental condenser. 3. So the geometry dictates how things combine to form more complex fields at each stage.
So the geometry guides the combination process, and the initial inputs, the basis of the cascade, could be those really basic structures we talked about way back.
Exactly. The inputs at U1 could be fields derived from the fundamental proto-simplex, or those 4 elementary syntrometrics types. And just like with the metroplexes, the source stresses again that those Kontraktionsgesetz, the complexity management rules, are vital here too. They ensure the cascade produces stable, meaningful results, not just mathematical noise.
Right. This is where Heim starts drawing some really fascinating analogies, isn't it? Connecting this abstract cascade process to things we might actually recognize.
Yes, this is one of the most intriguing parts, definitely. Heim explicitly suggested that these Strukturkaskaden mirror stages of cognitive processing.
How so?
Like how raw sensory input gets processed through successive layers of abstraction in the brain to form higher-level perceptions, concepts, and thoughts. The cascade architecture reflects that hierarchical processing.
And he also compared it to
artificial neural networks. He saw parallels between the cascade structure, the layered processing, the way complexity is managed, the formation of feature maps, and the architectures being developed in early AI. Pooling layers in ANNs, for example, perform a function somewhat similar to contraction.
That's a really powerful conceptual link. This abstract structural framework seems to map surprisingly well onto the architecture of information processing in minds, maybe both natural and artificial. Which brings us right back to consciousness again.
Exactly. The source suggests the speculation that Ich-Bewusstsein, self-awareness, could potentially emerge as a particularly stable holoform, remember? The integrated structure with holistic properties.
Yeah.
Existing at the very Kaskadenspitze, the peat, of a sufficiently complex and highly integrated cognitive cascade. It's like the ultimate outcome of this structured processing reaching a state of high coherence and self-integration. He even tried to link this to observable brain activity patterns like EEG.
Wow. So the same framework that aims to describe building basic structures, scaling complexity, modeling quantity, might also describe the very architecture of consciousness as the pinnacle of a structural cascade. And Heim claims this framework goes even further right down to fundamental physics.
That's perhaps the most audacious part of the whole theory. He makes a really crucial move here.
Yeah.
He shifts away from the continuous fields often used in physics and postulates that reality, at its most fundamental level, is actually discrete.
Discrete. Why? What drove that?
He argued it was driven by physical considerations, specifically something he called the Televariansbedingung, a condition related to invariance, which he interpreted as implying that physical coordinates themselves must be quantized, not continuous, but existing in minimum units.
Quantized coordinates, like pixels of reality.
Right.
What's the fundamental unit in this discrete space he proposed?
He called it the metron, symbol E. It's conceived as an indivisible quantum of extension, the smallest possible chunk of space-time, if you like. These metrons form a fundamental grid, the metronisch Gitter, or metronic lattice, underlying everything.
Okay, a basic grid.
And working with this grid requires a different kind of math, a metronic calculus, a form of discrete mathematics.
Right, a discrete math for a discrete reality. So how do physical things like particles actually appear in a system built on this grid?
Through something Heim calls metric selector theory. The idea is you start with abstract geometric blueprints, tensorion, which are like universal archetypes for stable forms.
Okay, abstract blueprints.
These blueprints are then acted upon or filtered by geometric operators, like that 3-ana, the fundamental condenser, or a structure compressor for you. These operators function as selector operatoren.
Selectors.
Yeah, they select valid structures by imposing Eigenwertbedingungen, eigenvalue conditions. The specific eigenvalues that satisfy these conditions correspond to the allowed, quantized physical properties like mass or charge.
So fundamental physical properties emerge as the necessary mathematical outcomes, the eigenvalues, when you apply geometric rules, the operators, to these abstract structural blueprints.
That's the core idea, yes. It's quite abstract. Then these selected abstract blueprints get realized or projected onto the actual physical metronic Gitter. This involves specific procedures, Metronisierungsverfahren, which use various selectors like a metrische Sieb operator to ensure the structure is compatible with the discrete lattice.
And the result of this realization?
The result is the formation of metronisch hyperstructuren. These are the candidates in Heim's theory for fundamental particles. They are the stable, ordered structures realized on the grid. The degree of order achieved is quantified by structure condensation.
And this is where Heim makes one of his most specific and probably most debated claims, connecting this whole abstract machinery to actual physics, right?
Absolutely. The source highlights his claim to derive the existence of exactly 6 physical dimensions and R6 reality directly from the mathematical conditions required for these metronisch hyperstructures to be stable and form consistently on the metronic lattice.
6 dimensions, derived not from observation initially, but from the internal consistency requirements of forming stable structures on a fundamental grid. That's a huge conceptual leap.
It is a massive leap, and he didn't stop there. He further tried to connect this abstract 6D structure back to concrete physics by deriving a combinatorial factor, LP equals 6, choose P.
6 choose P like combinations.
Exactly. This factor, which arises mathematically from the ways you can choose dimensions out of the 6 available ones, plays a absolutely crucial role in his proposed particle classification scheme, and even in the specific mass formulas he developed later. He tried to link the abstract dimensional structure directly to predicting observable particle properties.
There's just an incredible scope,
Yeah.
truly from subjective viewpoints all the way down to proposing the fundamental grid of reality, deriving the number of dimensions, and calculating particle factors. The source even mentions a comprehensive Formelsammlung, a formula register.
It does, yeah. It apparently compiled the key mathematical expressions, trying to show the formal connections across the entire arc of the theory, from subjective aspects and structure building through dynamics and scaling to quantifying reality and proposing a framework for fundamental physics, including those particle-related factors.
Okay, let's just try to quickly recap this immense journey Heim's theory takes us on. It kicks off with the simple idea that perspective matters, right? Formalizing subjective viewpoints, the relativity. Then it goes hunting for universal truth, proposing the syntrics as this universal engine for building any kind of structure from absolute fundamentals.
Right, using the scintillator rule on the metrophor.
We saw how these structures combine, using corporators, forming stable jumbled, including those really interesting holoforms with emergent properties.
And the claim that combination itself is a universal truth.
And then how systems evolve dynamically, guided by this intrinsic purpose, telecentric, towards stable goal states, telezentrin, capable even of these radical leaps, transcendence, to totally new levels of reality.
Addressing strong emergence.
We explored how it handles scaling complexity infinitely with metroplex theory, systems of systems, but keeps it manageable using contraction.
That crucial complexity management.
And then we saw the attempt to apply it all. Modeling quantifiable reality with quantitative syntrics, processing fields in these structure cascading that look uncannily like cognitive or neural network architectures.
Leading to speculation about consciousness at the cascade peak.
And finally, the most audacious step, proposing a discrete metronic getter for reality using geometric selectors on structural blueprints to derive fundamental physics, claiming to explain 6 dimensions and particle properties.
It's, an immense and incredibly ambitious theoretical structure. The so what here, I think, isn't just about whether the specific physics claims hold up. They're highly speculative, very debated.
Yeah.
But it's the sheer scope of the attempt. It's this unique effort to build a single, unified framework covering structure, information, purpose, emergence, cognition, and physics, all supposedly derived from first principles of consistency, stability, coherence. It's a really fascinating mix of logic, geometry, systems thinking, and honestly, a pretty deep philosophical viewpoint.
It definitely gives you a lot to chew on. This deep dive has really just sketched the outline of a vast, complex theoretical landscape. It raises some absolutely profound questions about what reality fundamentally is and how complexity comes about.
Absolutely. It challenges you to think differently.
So maybe here's a final thought to leave you with, something to mull over based on this whole framework. What if you consider the idea that the most fundamental stuff of reality isn't particles and forces in the usual sense, but maybe pure structure and the relationships between structures? And perhaps consciousness isn't some weird anomaly, but something that emerges quite naturally as a particularly complex, stable, self-integrated pattern within that universal structural geometry. What would it mean if purpose telecentric wasn't just a feature of biology, but was proposed as an inherent principle guiding the universe's evolution towards coherence? Thinking about your own world, how you organize things, the systems you're part of. Can you see any structures or processes striving towards coherence that maybe, just maybe, resonate even faintly with these incredibly abstract principles?